Cool, 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 cool. Oh, this would have changed again then. Shit. So my head hurts right now. I don't know what to say. You know what? I'll edit later. I'll just edit later. Alrighty, danky do. Howdy all. Okay. Just checking. Okay, I'm live here this time now. Okay. Yeah, I'll just go and remove this stream on my content channel. It's like, I don't know, sometimes just things are just too annoying for me. Okay. Guess it continued, right? Huh. Okay. Now. You guys can't hear, you won't be able to hear anything I say. Or sorry, the one that will come in the video because okay, now it should be good. If I type anything. Let's see.
To module 3 of the Getting Started.
Cool. So yeah, hopefully you guys are doing well. Now, what we are going to do here is let me reduce the gain a bit. So this is much better. Cool.
Started with Terraform.
Okay. Yeah, what I'm going to do is now start working on the how to write the infrastructure code, which is our main basically IAC infrastructure code for Google Cloud using Terraform. As I was saying before, right? I'll just share my screen here. Last time we talked about various commands, validator, terms, what is providers, how to download like the basically like for example if you're doing for Google, how to download all the necessary CDK, all those things which come with Terraform, how to find the versions, right? So we did all of that. What is the workflow? We even had the lab where using command line or Terraform, basically we were able to change the type of machine from small to medium, I believe, and even change the networking configurations and saw what were the errors, common errors, and things like that. We did the quiz and a summary. Now we are going to work towards writing infrastructure code, right? Here it will cover module overview, introduction to resources, arguments for resources, resource dependency, variable best practices, output value, Terraform registry, Cloud Foundation toolkit. Okay, this will be interesting if you're talking about Cloud Foundation. And just for like better, because with this, if I connect myself to here, I'm able to hear myself, which like is pretty weird. Right now I'm connected to my this microphone. So I'll just connect to my AirPods and I will change the output audio. So it's easier. Okay, let's see if you guys can hear. No.
Deeper into resources.
Cool. Hopefully you guys are able to hear. I'll just check with my phone just to make sure You guys are able to hear this? The quality is hell of bad. Holy shit. What? The quality is hell of bad. Can I change the quality right now? Okay, let's see. It's like coming as 240 pixel here. Mate. Check a mate. Let's search. Let's see where I'm online. I'm live. Okay, here I'm live. Quality. I can change here, right? Let's see. This is good. This is good quality. Okay, never mind. My phone is idiot. My phone is actually cracked. So this is good. Okay, cool. Let's just. So sorry. I'm going to eat and like yawn a bit in the middle. But yeah, let's get started with our whole learning process. Remember to first learn, then earn. Module overview, writing code.
Hello again. Welcome to Module 3 of the Getting Started with Terraform for Google Cloud course, where you'll dive deeper into resources, variables, and output values, and learn how to write infrastructure code for Google Cloud. This module focuses on the first phase of the Terraform workflow, the author phase. During this phase, you'll write your code in the Terraform language, HCL. This module begins by exploring how to create infrastructure components using resources, and then discusses how Terraform handles dependencies within those resources. You'll learn how to parameterize a configuration using variables, and walk through the syntax used to declare and define them within your configuration. You'll then learn how to use output values to export resource attributes outside the resource declaration. This module also explains how to simplify code using the Terraform registry and Cloud Foundation toolkit. You'll conclude with a lab to apply what you've learned. Let's get started. The first topic in this module is resources. Let's get started with an introduction to resources before jumping into meta-arguments and dependencies. In the Terraform world, resources are infrastructure elements, such as compute engine instances and cloud-stored buckets. These elements can be configured with Terraform code. Real-world infrastructure has a diverse set of resources and resource types. Terraform uses the underlying APIs of each Google Cloud service to deploy your resources. Resources include instances, instance templates, groups, VPC networks, firewall rules, VPN tunnels, cloud routers, and load balancers. Resources are defined cloud router.
So basically, if you understood what Terraform does, like you can use the Google CLI to provision or anything, do anything with it. But Terraform is automating that stuff, basically.
And load balancers. Resources are defined with a .tf file. It's recommended that you place similar types of resources in a directory and define the resources in the main.tf file. In this example, main.tf is the root configuration. The resource block is used to declare a single infrastructure object. The resource type identifies the type of resource being created and depends on the provider being declared within a Terraform module.
So basically, for every resource, so if you're creating two VPC, create two resource blocks instead of one, and stuff like that.
Resource being created and depends on the provider being declared within a Terraform module. A provider is a plugin that provides a collection of resource types. Generally, a provider is a cloud infrastructure platform. In this course, Google Cloud is the provider. Resource arguments use expressions to declare attributes. Some resource arguments are mandatory for resource creation, and others are optional. Attributes can be used to define any advanced features associated with a resource. You can include multiple resources of the same or different types within the same Terraform configuration file. These resources can even span across multiple providers. Here, the first resource block declares the VPC network, and another declares the subnet. Both resources are in the same main.tf file. Let's examine a couple of more resource blocks. A resource is a subnet.
Pay attention to something this here on the third line here, network, Google Compute Network, name, the another label, right? And its ID. So whatever will be the output of this, you get the ID, not the project ID, but the ID of the VPC that will be put here. IPCIDR is basically how many IP ranges you want. /22 decides that, and 10 will tell okay, this will be the starting one, starting address. Regions and stuff are pretty simple.
Both resources are in the same main.tf file. Let's examine a couple of more resource blocks. A resource is identified by the resource keyword, followed by the resource type. This example shows a VPC resource named VPC_network, which is of the type Google_compute_network. The name is required for the Google_compute_network block, but other arguments are optional. You can also define advanced features such as versioning within the same block. This example defines a VPC subnet called subnetwork-IPv6. For the subnetwork block, the name, the network in which the subnet should be created, and the IPCIDR range are required. Notice the resource arguments depend on the resource type. This means that the network includes the arguments such as name, project, and auto-create subnetworks. And the subnetwork includes arguments such as name, IPCIDR range, and network. When accessing a resource attribute from another resource block, use the format resource type.resource name.attribute.
Yeah, so I was saying, basically, was also like we talked about last time, and this was also in the Google Cloud documents we went through, where we were talking about like some of the best practices on how to do it, right? If you see, all are equal. So I'm just reiterating over those stuff because like I think it's important to understand those things, right? So this is underscore being used. Here inside will be dash, uh, dash. I will say dash, underscore and dash, whatever, hyphen. I think hyphen. Yeah, I'm bad with these things. But yeah, then all the equals are like this, right? So it's very important to follow these things because if you follow a convention, great part about that will be, let's say, if every developer follows the conventions, right? Whenever you are taking over somebody's work, you're going back to your own work, or somebody else is taking your work. The effort and the hardship of like understanding what they were doing goes like very low if everybody's following a proper method, if you or a standard. If you don't, or if you, first of all, if you don't use it, you think, oh, I don't care about other ones. Let me tell you, you're not going to learn, and if everybody else is following it, you won't learn how their method work. You eventually have to learn and start following, because if you go to another company too, right, in your current company you're not doing it, in future company you go, they might be doing it, you have to learn it again, right? And if you, this is how people at good companies get fired. One is, of course, productivity. Second is like, this kind of is under productivity and standards. If you don't, it's pretty bad. So just want to iterate over that really well.
You can also define advanced features such as versioning within the same block. This example defines a VPC subnet called subnetwork-IPv6. For the subnetwork block, the name, the network in which the subnet should be created, and the IP-CID or range are required. Notice the resource arguments depend on the resource type. This means that the network includes the arguments such as name, project, and auto-create subnetworks. And
So what this means is based on the type of resource we are creating, like name, project, all these are required. In compute engine, it might be like how much virtual CPUs, basically how much CPUs you need, how much RAM you need, what will be the storage attached to it, which region it will be put in, which subnetwork, VPC, all those stuff, depending on what you are uh, initializing, whatever you're provisioning. Based on that, these things will change.
is name, project, and auto-create subnetworks. And the subnetwork includes arguments such as name, IP-CID or range, and network. When accessing a resource attribute from another resource block, use the format resource type dot resource name dot attribute. In this example, when a subnet is created, the subnet requires the network ID of the VPC network it belongs to. The network ID is a computed resource attribute of a Google _compute _network block. The attribute is generated
So this is the type, name, and the ID.
when the network belongs to. The network ID is a computed resource attribute of a Google _compute _network block. The attribute is generated when the network is created. The subnet resource block uses the network ID created from the VPC _network block and uses the format Google _compute _network .vpc _network .id.
So VPC network might have property called network ID, but for Terraform it uses ID, right? So Terraform takes the network ID and shows it as network or just ID, right? Takes the network ID, show it as ID. So that's one thing people have to do research on, or like whenever you're creating, just do quick Google or like go to the docs.
This method can only be used when resources are defined in the same root configuration. When defining a resource block, there are important factors to consider. First, a declare resource is identified by its type and name. Therefore, the resource name must be unique within the module. The resource type is a keyword associated with the provider and cannot be user defined. A cloud storage bucket is associated with the Google Cloud provider and is defined by the keyword Google _storage _bucket. Any other name would result in an error when Terraform plan or Terraform apply are run. All configuration arguments must be enclosed within the resource block body, which is between the curly brackets. An infrastructure element and its associated attributes are defined within a resource block. A Terraform configuration will not pass through the plan and apply phases successfully without all the required arguments defined within the configuration. Will
I
not
don't know why it's
pass.
a stupid config. Those things are coming, but yeah. So important part from my side, like my takeaway to you guys will be just have best practices written somewhere, like in your notes or somewhere, and those should be more than enough to keep you going all the time with these issues and save you from these issues rather.
Through the plan and apply phases successfully without all the required arguments defined within the configuration. Let's transition and examine resource meta-arguments. The Terraform language defines several meta-arguments, which can be used with any resource type to change the behavior of the resources. Count creates multiple instances depending on the value you define. For each creates multiple instances according to a map or set of strings. Depends on is used to specify explicit dependencies. Lifecycle defines the lifecycle of a resource. With the lifecycle argument, you can prevent the destruction of a resource for compliance purposes and create a resource before destroying the replaced resource. This approach is often used for high availability. Provider selects a non-default provider configuration. You can have multiple configurations for a provider, including a default.
So basically, if there are multiple providers you're using, like Amazon, AWS, Microsoft Azure, Google, with provider, you can set one default, like there will be one default setup, and others you can also use.
This course covers count and for each in detail. Let's start with the count meta argument. Perhaps you want to deploy multiple VM instances. In the resource definition here, each compute engine instance is created with a separate Google underscore compute underscore instance resource block. Writing code in this way is redundant. Instead, replace the redundant code by adding the count argument at the beginning of the resource definition. The count argument tells Terraform to create 3 instances of the same kind. The expression on the second line, count.index, represents the index number of the current count loop.
My apologies. I just want to make sure the with the scene and OBS, like things are actually going through, like there's stats are good and stuff like that, like this stream live, all those things. So I just want to make sure sometimes I do check these things in between. Um, that's good to check and all those things, right? No harm in these things. And one more thing I would like to add to the scene is like called strength of how things are going. Thus I see all these juggernaut stuff. Uh, this is hard. Like these things like this streaming, like maintaining, making sure everything is okay. When you don't have somebody with you all the time is hard. But that's fine. Okay. Sweet. Let's go back.
To create 3 compute underscore instance resource block. Writing code in this way is redundant. Instead, replace the redundant code by adding the count argument at the beginning of the resource definition. The count argument tells Terraform to create 3 instances of the same kind. The expression on the second line, count.index, represents the index number of the current count loop. The count index starts at 0 and increments by 1 for each resource.
Basically, like as
Include the
encoding.
count index variable in strings using.
So the index starts basically. Index is like I'll create a video on arrays and index. I think that will like give you a really good picture of how things work. But index always start from zero. Remember that.
The expression on the second line, count.index, represents the index number of the current count loop. The count index starts at 0 and increments by 1 for each resource. Include the count index variable in strings using interpolation. When deployed, Terraform names the instances dev underscore VM1, dev underscore VM2, and dev underscore VM3. If your instances are almost identical, count is appropriate. If some of their arguments need distinct values that you can't directly derive from an integer, then it's safer to use for each. The for each argument can be assigned to a string. If your instances are almost identical, count is appropriate. If some of their arguments need distinct values that you can't directly derive from an integer, then it's safer to use for each.
Okay, so if it's everything is excuse me. So everything is has like same arguments, right? Like zone, region naming, and similar naming, right? But for different zones or different regions in two set.
The for each argument can be assigned to a string of values or a map. Terraform will create one instance for each member of the string. Consider a scenario where you need 3 similar instances configured in 3 specific zones and want the names to have zones as prefixes for identification. Instead of writing lengthy repetitive code, you can use the for each argument to assign specific values. The example code creates 3 instances in the respective zones: Dev US Central 1, Dev Asia East 1B, and Europe West 4A. Zones.
So here it is for each using toSet to do this. I'll just type here this for underscore each, right? To set. Interesting toSet is like put as um everything is small, like set is not given like a B, like a bigger um how to say capitalized, it's not capitalized, it's like there's no camel casing type thing. And I'll do something like this, right? And then with this chat, you can also have a look at the. I'll post everything on the blog as well. Yeah,
Dev US
we can just
Central
move to
1,
next.
Dev.
But this
Next
is
up are
important.
resource dependencies. While
To access the value, you can do each, right? Use the each, and then I think it's called one is each value, one is each.
Let's transition an example US.
So each value, yeah. So each value, and even here for the name, it's zone says each value.
Next up are resource dependencies. While building an infrastructure, you may prefer to have a visual representation of how your infrastructure is connected and interdependent. A dependency graph helps you understand your infrastructure before deploying it. Terraform builds a dependency graph from your configurations to generate plans and refresh state. The attributes are interpolated during runtime, and primitives such as variables, output values, and providers are connected in a dependency tree. Terraform creates a dependency graph to determine the correct order of operations. In more complicated cases with multiple resources, Terraform will perform operations in parallel when it's safe to do so. Terraform can handle in more complicated cases with multiple resources, Terraform will perform operations in parallel when it's safe to do so. Terraform can handle 2 kinds of dependencies, implicit and explicit. Implicit dependencies are known to Terraform, whereas explicit dependencies are unknown. Sometimes one resource creation depends on information generated from another. For example, you cannot create a compute instance until the network is created. Similarly, you cannot assign a static IP address for a compute engine instance until a static IP is reserved. These depends on information generated from another. For example, you cannot create a compute instance until the network is created. Similarly, you cannot assign a static IP address for a compute engine instance until a static IP is reserved. These dependencies are unknown. Sometimes one resource creation depends on information generated from another. For example, you cannot create a compute instance until the network is created. Similarly, you cannot assign a static IP address for a compute engine instance until a static IP is reserved.
Yeah.
These dependencies are implicit. There are other scenarios where you induce a dependency. A given resource can only be created upon the creation of another resource. In such cases, you would want to explicitly mention dependencies that Terraform cannot see.
So, for example, I have a good example for this. Let's say you have a database system for your staging, production, or dev environment. Let's say for dev environment, right? Hey, do not start the server unless and until the database is already there. Or hey, do not create the database unless and until the network, the virtual private cloud or the subnet is already there. So, two dependencies, both are explicit. That's how you mention.
For example, let's say you use a specific cloud storage bucket to run an application. That dependency is configured inside the application code and not visible to Terraform. In this scenario, you can use depends on to explicitly declare the dependency. Let's take a closer look at how Terraform
This is also used like in from my experience, I can say it's also used in um, what's this called? Amazon, right? What's this? I think it's called ECS stars definition, where we are telling, if let's say there are multiple, ECS is basically, um, think of it similar to Kubernetes, right? Where you have like multiple, um, the word, right? Word, multiple containers, right? But some containers are dependent on other, so you want certain containers to be started first and made sure they are healthy and working compared to others, right? So in that case, we use something similar in the ECS stars definition as well, depending on, oh, hey, start this container once this container is already in. Same thing here, right?
dependency. Let's take a closer look at how Terraform handles implicit dependencies using another example. Here, the compute instance, my instance, is created in a custom VPC network called my network. In Google Cloud, you cannot create a compute instance without a network. Terraform is informed of these relationships by interpolation expressions. Interpolation expressions should be used whenever possible. The reference to my network in the network argument creates the implicit dependency on the network mentioned in the Google _compute _network block. When you run Terraform apply, you can view the order in which resources are created. Terraform by default knows this order. Because of implicit dependency, Terraform is able to infer a dependency and knows it must create the network before creating the instance.
The good part is you don't have to, kind of good part is depending on your standard, is you don't have to put instance after network. You can have network before, but and this is good in terms, let's say if you have like multiple virtual machines, virtual networks, databases, virtual private clouds, right? All instances are in this chunk. Network is in this chunk. Storage is in this chunk. And they are interdependent, right? Some are dependent, right? Instead of like um, going like that, will be good. Terraform apply will be good to see, okay, which one will be created first. Okay, first network will be created, then database storage, then databases, then storages, then instances.
In this example, Terraform creates the VPC network, my network, before creating the compute instance named my instance. When Terraform reads a configuration, it will first ensure that my network is created before my instance. Then save the properties of my network in the state. And set the network argument in Google _compute _instance to the value in the name argument in the Google _compute _network block. Next, let's examine explicit dependencies, which are not visible to Terraform. Explicit dependencies are defined with the depends on argument within a dependent resource block. The depend on argument
A non-dependency is defined. So these what Terraform cannot tell. Two servers are related to each other. One database, because instance depends on the database, stuff
explicit
like that.
dependencies are defined with the depends on argument within a dependent resource block. The depend on argument gives you the flexibility to control the order in which Terraform processes the resources in a configuration. Depends on can be used within a module block regardless of the resource type. The value can be an expression that directs to the resource. For example, let's say you need to create two VMs, a server and a client, and you want the client VM to only be created upon successful creation of the server VM. This dependency is not visible to Terraform and has to be explicitly mentioned. You can use depends on to explicitly declare the dependency of the client VM on the server VM. So, where in your configuration should these resource VMs be mentioned? You can use dependency is not visible to Terraform and has to be explicitly mentioned. You can use depends on to explicitly declare the dependency of the client VM on the server VM. So, where in your configuration should these resource dependencies be defined? The order in which the resources are defined has no effect on how Terraform applies your changes. So organize your configuration files in a way that makes most sense to you and your team.
So basically, you can define in the terms of region, right? Hey, I want to define regions. This region first, like US Central first, then for Canada, then for Singapore, Asia Central, UK, Europe, or like based on time. Okay, first from Japan, then China, India, UK, uh, Mexico, US, Canada, based on time, or you can just say all instances here because all they are making the same servers. All storage is here because they are similar, just the regions are changed, however you like, right? So
Upon
important is you should have a standard. That's the most important part. Define a standard. If you don't define a standard, let me tell you, you are going to like have a really hard time. Because if you don't create standards, that can create issues later. A lot of issues. Not going to lie.
executing Terraform apply, you will notice that the client VM is created after the server VM. During interpolation of expression, Terraform processes the resources specified in the meta argument depends on and creates the server VM before creating the client VM. Depends on and creates the server VM before creating the client VM. So far in this module, you've been
I'm just thinking, is there a way to remove suggestions? Account loop, copy video URL. Stats for nerds. Yay.
hard. So far in this module,
Nerds
you've been
created
hard
Go
coding
garbage.
resource argument values. But what if you wanted to parameterize your configuration and define argument values during the apply phase of the Terraform workflow? Perhaps you wanted to standardize your code but maintain the flexibility to customize resource attributes at runtime. This is where variables come in. With variables, you can parameterize values shared between resources. Input variables serve as parameters for Terraform, allowing for easy customization and sharing without having to alter source code for runtime. This is where variables come in. With variables, you can parameterize values shared between resources. Input variables serve as parameters for Terraform, allowing for easy customization and sharing without having to alter source code. After a variable is defined, there are different ways to set its value at runtime, including environment variables for easy customization and with variables, you can parameterize values shared between resources.
Hmm.
Input variables serve as parameters for Terraform, allowing for easy customization and sharing without having to alter source code. After a variable is defined, there are different ways to set its value at runtime, including environment variables, CLI options, and key value files. In the code shown in the example, the name, location, and storage class are hard-coded. You can declare any of these attributes as a variable and specify the details at runtime. Variables separate source code from value assignments. Let's explore how to declare an input variable. Variables must be declared in the variable block.
Let's pay attention to this for a second. Variable parameterize your configuration without altering the source code. So basically, if there are multiple variables you are setting up, right? Like for virtual machine instance, you can use for location if they are all going to be in US, you can just define US. But if they are different, that's fine. You for let's say the type, operating system, virtual machine, RAM, all those. If even if you are serving in different nations, let's say then traffic is similar in all the nations or certain nations, just define that nation 1, nation 2, nation 3, tier 1, tier 2, tier 3, right? So that makes sense. That's a good thing. Variables allow you to assign a value to the variables attribute at the right runtime. So runtime, the variable value will change into the value given, right? Another simple one, nothing much crazy. um, Variables separate source code from value assignment. Variables separate source code. So source code will be different. Without variable, resource arguments are hard coded. So hard coding is not a good thing majority of the time. So with that being said, I believe then based on that it makes sense. Variables separate source code. So variables will be separating source code from value assignment. Okay.
Variables
Not
separate
most
source
clear
code
though.
from value assignments. Let's explore how to declare an input variable. Variables must be declared in the variable block. It's recommended that you save all variable declarations in a separate file named variables.tf. The label next to the keyword variable gives the variable a name. There are two rules for naming variables. First, the name of the variable must be unique within a module. Second, variable names cannot be keywords. There are no requirement arguments for a variable, so a variable block can be empty. Terraform can automatically deduce the type and default values. The type argument specifies the value types that are accepted for the variable. Terraform supports the following primitive variable types: bool, which is used for binary values such as true or false without the quotes; number, which is used for numeric values; and string, which is used for a sequence of Unicode characters. Default is another meta argument used to assign a default value to an attribute. To access the value of a variable declared within a module, you can use the expressions var.variablename. In the example on the slide, characters. Default is another meta argument used to assign a default value to an attribute. To access the value of a variable declared within a module, you can use the expressions var.variablename. In the example on the slide, the variable bucket underscore storage underscore class is formatted as var.bucket underscore storage underscore class in the resource block. The name of the variable in the variable block has to match the reference made within the resource block. The default value can be overridden by assigning a value in environment values, or in the .tf var files, or using the -var option. The folder
I just realized my mic was off. Apologies for that. So what I was talking about here is that, so if we just put something as default and dot, and if we don't put anything, storage class will get whatever is the default value or whatever we did, right? So this is kind of okay. I'm just thinking it will be like dangerous for a person like me, because if I just forget, then it will give wrong value and I will be like stuck, kind of stuck. Maybe, but can be used, the default can be used like for locations and stuff. Like my majority of the infrastructure I put is in Canada Central, because that's closest to me, not Canada East. So maybe, huh?
underscore storage underscore class is formatted as var.bucket underscore storage underscore class in the resource block. The name of the variable in the variable block has to match the reference made within the resource block. The default value can be overridden by assigning a value in environment values, or in the .tf var files, or using the -var option. The folder structure shows that the variable declaration is written within the variables.tf file, which is a recommended best practice. The variable is assigned to the storage underscore class argument.
I, I was searching for flag dash var where he mentioned like here, right? So I'm just looking at, okay,
within the var option, or in the .tf var files, or using the -var option.
dash var option, right? So option in Terraform. Options. Oh, okay, options. Terraform apply CLI, API, UI, destroy mode. Okay, apply only. Dashboard. Run mode options. You know what I'll just do? I'll just do a trick, which is a hacker trick, and that works for me all the time, right? Um, I'm just going to use Terraforms like basically this. Hopefully, this is better. Terraform. There is stuff. Output providers. And the thing where is var option. Facelift. We are going to do Kubernetes too soon. Man. I need to fucking. Okay, FMT format in it. Okay, here. That's what. Okay, boy. Apply. So apply. Under apply it is, right? Environment you can put. Under apply it is. Specify number of operations, right? But like in the variable you can just define like this or var file.tf vars. So here, just like here, so we have to, even with the plan, apply plan. So for in apply, he might have mentioned already that we are using variables.tf file or tfvars can be used like we saw in the example. That's crazy.
Or in the .tf var files, or using the -var option. The folder structure shows that the variable declaration is written within the variables.tf file, which is a recommended best practice. The variable is assigned to the storage underscore class argument. The default value in quotes is used when creating the resource. The description documents the purpose of the variable. The description is displayed during the apply phase when the variable doesn't have a defined value. The description should explain the purpose of the variable and the expected value. The description string is often included in documentation, so it should be written from the perspective of the user rather than its maintainer. Comments
The description is an interesting one to have.
when the variable documents the purpose of the variable. The
Let's go back
file
a little.
which is
Let's
a
see.
recommended best practice. The variable is assigned to the storage underscore class argument. The default value in
Mm-hmm.
quotes is used when creating the resource. The description documents the purpose of the variable. The description is displayed during the apply phase when the variable doesn't have a defined value. The description should explain the purpose of the variable and the expected value. The description string is often included in documentation, so it should be written from the perspective of the user rather than its maintainer. Comments can be used by the maintainer. Sensitive, as the name suggests, is a variable argument used to protect sensitive information from being displayed in command outputs or log files. The acceptable value for sensitive is true. When set to true, the value is marked sensitive in the output of Terraform plan or Terraform apply. This argument is beneficial when dealing with information such as database credentials or API tokens. Marking variables as sensitive will eliminate access.
So this is like Jenkins. When in Jenkins you can like mask. It's called masking. So the credential here is sensitive. There will be the asterisk 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 the star 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 in Jenkins. So this is used. Terraform is used in CI/CD, right? So you use this to save.
Terraform apply. This argument is beneficial when dealing with information such as database credentials or API tokens. Marking variables as sensitive will eliminate accidental exposure of confidential information. In this example, the user information variable is marked sensitive. The resource foo uses name and address, which are both sensitive variables. When Terraform plan or apply is run, values are not displayed because they are marked as sensitive. Plan in variables as sensitive will such as dan or Terraform apply. This argument is sensitive information from being displayed in command outputs or log files. The acceptable value for sensitive is true. When set to true, the value is marked sensitive in the output of Terraform plan or Terraform apply. This argument is beneficial when dealing with information such as database credentials or API tokens. Marking variables as sensitive will eliminate accidental exposure of confidential information. In this example, the user information variable is marked sensitive. The resource foo uses name and address, which are both sensitive variables. When Terraform plan or apply is run, values are not displayed because they are marked as sensitive. There are several ways to set variable values at runtime. First, you can use .tfvar files to quickly switch between and
Mm-hmm.
version sets of variables. You can also use CLI options. CLI options are useful for running quick examples on simple files. Environment variables are used in scripts and pipelines. If a required variable has not been set using one of the described methods, you can use the CLI prompt. When you have many variables are used.
So prompt will be coming with CLI environment variables. TFVAR project ID is equal my project. When we do TF apply, oh, this is a slash, so they're part of similar same command, right? TF apply, it will use this one. Interesting stuff, man.
Used in scripts and pipelines. If a required variable has not been set using one of the described methods, you can use the CLI prompt. When you have many variable definitions to input, providing the value in the command line might not be feasible. Instead, specify the variables in a definitions file with either a .tfvars or .tfvars.json extension. Variable definitions follow the same syntax as HCL, but include only the variable name assignments. Terraform automatically loads variable definition files as long as they are exactly named terraform.tfvars, terraform.tfvars.json, .auto.tfvars, or .auto.vars assignments. Terraform automatically as HCL, but include only the variable name assignments. Terraform automatically loads variable definitions and
Need to go
extension.
back to this one.
Variable definitions follow the same syntax as HCL, but include only the variable name assignments. Terraform automatically loads variable definition files as long as they are exactly named terraform.tfvars, terraform.tfvars.json, .auto.tfvars, or .auto.tfvars.json.
If
The
any
definition provided in the .tf
if any of these things start with dot in the start, right? Any of the names, they are hidden. Remember that.
var files overrides the definition in the default argument and environment variable. If you want to specify the value of a variable individually on the command line, you can use the -var option. These values can be entered when running either Terraform plan or Terraform apply. This method is frequently used for automation, where the -var is sourced from another environment variable. It's also useful when running quick examples on simple files. If you use a .tf extension, you must specify the file name using the -var-file option on the command line. Set variables can be overridden at deployment. You can reuse the variable file and still customize the configuration at deployment. The -var option takes the highest precedence over all other variable assignment methods.
Mhm.
If the variable value is assigned using multiple methods, the value defined using the -var option is the value that is assigned to the variable. If a
That's actually
required
good.
variable has not been set using a described method, Terraform prompts you on the CLI. In this example, the variable has not been parameterized and has not been assigned a value. Therefore, the CLI prompts you to enter a value during the plan phase. You can also validate the value assigned to a variable.
This is example of like, when you are, let's say, opening any file, right? It asks for the, let's say, for example, if you are into hacking, like me, there's something called Metasploit, right? You put the host you want to hack, you put the IP, it comes up with the prompt, type of hack you want to use, type of payload you want to do, type of like vulnerability you are looking for, or type of act you want to do, right? Do the payload, do a network analysis. Similar to that, it's come. You do the plan, it's looking for a variable, it don't know, it will come with a prompt.
To enter a value during the plan phase. You can also validate the value assigned to a variable by including a validation subblock with the variable block. The validation block includes a condition argument for which the validation rule is assigned. In this example, contains is used as a condition argument and validates the storage class's uppercase and an accepted value.
Hmm. So here, wait, hold. No, don't go back.
The storage class's uppercase.
So validation condition contains this dot of add or so this comes after. So in this to explain, right? We are asking the whoever is creating this provisioning this resource, we are asking that user developer person, hey, what type of value, right? Enter the value of the region, basically. What type, basically, of the storage class you want. You want regional, multi-regional, or standard. Standard would be zone. So he put zonal. Zonal doesn't exist. So that's when the validation comes. This I think will be very useful because this is also if you have developed IDs, if you have developed forms in emails, when you see in passwords, something similar use, and it's really good to have this because most important part of your whole ever development or any journey will be making sure data does not get corrupted because and you put checks multiple places. When I am doing development, when I was doing my projects, I put one in the front end. I put one when before sending it to API. Put one when it gets to the API in the back end. I put one when it starts interacting with the database. So it creates the JSON POJO, which is plain old Java object, which is the class one, converts to the SQL type row using JPA repository. That's where I use. So I use like 4 to 5 places for same thing.
Uppercase and an accepted value.
And that's how I got a job, right? Like I did it at 4 or 5 places. That's how I got a job because I was applying these things all the time. It's not like I was
Now that
like
you
doing
learned
it
how
on my own.
variables can be used in your configuration, let's explore some best practices for using them. First, only parameterize
Best practices makes or breaks you as a great programmer.
values that vary for each instance or environment. Variables can be used in your configuration. Let's explore some best practices for using them. First, only parameterize values that vary for each instance or environment. When deciding whether to expose a variable, ensure that you have a concrete use case for changing it. If there's only a small chance that a variable might be needed, don't expose it. Changing or adding a variable with the default value is backward compatible. Removing a variable is not. For root modules, provide values to variables using a .tf-vars variable file. Avoid alternating between var files and command line options. Command line options are ephemeral and easy to forget, and they cannot be checked into source control. Default variable files are more predictable. Give variables descriptive names that are relevant to their usage or purpose. Variables representing numerical values, such as disk size or RAM size, must be named with units. Google Cloud APIs don't have standard units, so following this naming convention clears the expected input unit for configuration maintainers.
So important here, I'm going to talk about, you know, this is my idea I'm getting with the examples here. RAM size GB. When you are doing developing of code, right? In your code, you have git commits. Git commit, one of the top part of git commits is your commit should be like small enough that it is like fast to read, but it should be like good enough that with just reading that one sentence or two sentence or one or two phrases, people get the idea what exactly happened to the whole commit. So that's why you make multiple commits every time you make changes, right?
Be named with units. Google Cloud APIs don't have standard units, so following this naming convention clears the expected input unit for configuration maintainers. To simplify conditional logic, give Boolean variable positive names, for example, enable external access. Finally, variables must have descriptions. Descriptions are automatically included in documentation and add additional context for new developers. We've covered
We covered a bunch of these. How much is these? I think these are also small. Let's see. How much is cloud
There are a
one?
couple of resources.
Lab intro. Okay. So we can, I think we can do these
In this lab,
three
you will
videos and
create.
we can create the lab, do the lab as well,
We've
right?
covered resources, meta arguments, dependencies, and variables. Let's wrap up by exploring output values. Output values are similar to return values in common programming languages. With outputs, you can view information about the infrastructure resources you created on the command line. Output values are used for several purposes. The most common use case is to print root node resource attributes in the CLI after its deployment. Most of the server details are calculated at deployment and can only be inferred post-creation. Output values are also used to pass information generated by one resource to another. For example, you can extract server-specific values such as an IP address to another resource that requires this information.
So here example of like this type of output value is like, we did like when we were provisioning an instance, Google instance, compute instance, we use the ID of a virtual network because you always need one of the subnets to put the virtual machine in it. That's the example.
Resources you created on the command line. Output values are used for several purposes. The most common use case is to print root node resource attributes in the CLI after its deployment. Most of the server details are calculated at deployment and can only be inferred post-creation. Output values are also used to pass information generated by one resource to another. For example, you can extract server-specific values such as an IP address to another resource that requires this information. Output values are declared using the output block. The keyword output indicates that the label associated with the keyword is the name of the output value. You can declare an output value anywhere within a configuration, but it's recommended best practice to declare them in a separate file named output.tf. The arguments that can be included within an output file
So
anywhere.
example of this is resource, we have picture, output value, we need the picture URL, description, what it value will be. I don't know why they put different. Google storage bucket. Oh, okay. So resource type, resource name and all those. It will be Google storage bucket object. This one, it's picture, where this is the resource type, this is the name, self underscore link.
Within a configuration.
One second, and I will remove this so you can see the page picture URL is this here when this is output, right?
But it's recommended best practice to declare them in a separate file named output.tf. The arguments that can be included within an output block are value, which is a required argument that returns a value to the user of the module. Description, which is an optional argument used to provide an explanation of the purpose of the output and the value expected. The description is often used for documentation purposes. And sensitive, which is another option argument used to mask the value of a resource attribute. This argument is useful to hide the accidental display of a resource attribute that is meant to be confidential, such as password information. In this resource purpose of the module, description, which is an optional argument used to provide an explanation of the purpose of the output and the value expected. The description is often used for documentation purposes. And sensitive, which is another option argument used to mask the value of a resource attribute. This argument is
Mask means hiding. That's what I was talking about when I was talking about Jenkins. It's like hiding those sensitive value. In Jenkins comes as star star. Here it comes at bracket and then sensitive.
Useful to hide the accidental display of a resource attribute that is meant to be confidential, such as password information. In this example, we have declared an output value for the object named picture. After the object is successfully uploaded, the object URL is displayed on screen. We recommend that you use output values instead of user-supplied inputs for the computed attributes of a resource. You can query all output values used in a project by running the Terraform output command. Let's explore best practice attributes of a resource. You can query all output values used in a project by running the Terraform output command. Let's explore best practice attributes of a resource. You can query all output values used in a project by running the Terraform output command. Let's explore in a
So here, let's take this example. Terraform output is here. We have resource this, VPC network this, output is network ID. In the same one, okay. Project ID is here, name VPC network. Output network ID for this ID will be given, self-link will be there when, okay.
Project by running the Terraform output command. Let's use for the compute project.
So, but like network ID is given with this and okay, I just don't understand why resource is put something like this here compared to output here and resource in different, right? Like main.tf, like that's my
by running the Terraform output command.
Spidey sense.
Let's explore best practices for output values. Only output useful information, such as computed information. Avoid outputting values that simply regurgitate variables or provide known information. For example, for a network resource, the following computed attributes are useful: ID, which is an identifier for the resource; gateway underscore IPv4, which is the gateway address for the default routing out of the network; and self-link, which is the URI of the created resource. As with variables, provide meaningful names and descriptions. Organize your code.
So like network ID, network name, output useful information of
IPv4 self-link, which is the URI of the created resource. As with variables, provide meaningful names and descriptions. Organize your code to include all output values in a file named output.tf. Finally, mark sensitive outputs. Instead of attempting to manually encrypt sensitive values, rely on built-in support for sensitive state management. When a value is marked as sensitive, the data is masked from the output of Terraform plan or Terraform apply command.
That's the important thing he mentioned here. Like, don't reinvent the wheel. These, if you are in like small or medium size startup, right, or enterprise where you cannot spend too much time or budget on these security or these things, a lot of time you will see support is already there. You don't have to do much or anything, right? Support is already there. Just use that support well. Just do a good research on these and you will be Gucci. You will be Gucci. You don't need anything else, right? That's the whole point. Let's close this. Now we are talking about last.
A couple of resources available to help you write infrastructure code for Google Cloud. The Terraform registry is an interactive resource for discovering a wide selection of integrations and configuration packages.
Terraform registry is like Docker registry. If you have not worked with Docker, think about it as GitHub of Terraform. Files.
To help you write infrastructure code for Google Cloud. The Terraform registry is an interactive resource for discovering a wide selection of integrations and configuration packages. otherwise known as providers and modules. The registry includes solutions developed by HashiCorp, third party vendors, and the Terraform community. The registry provides plugins to manage any infrastructure API, pre made modules to quickly configure common infrastructure components, and examples of how to write quality Terraform code. In addition, the Cloud Foundation Toolkit, also known as CFT, is available for you to use. CFT provides a series of reference modules for Terraform that reflects Google Cloud's best practices.
That will be in your
These modules can be
GitHub on
used to
Google.
quickly build a repeatable foundation in Google Cloud. CFT modules are also referred to as Terraform blueprints. With the Terraform registry, you can surface modules for all providers, such as Google, AWS, and so forth. CFT is a collection of Google Cloud Terraform modules built and maintained by Googlers. These modules are published to the Terraform registry. CFT modules let you maintain the IAM roles for multiple projects within the same module, as opposed to updating roles for each project individually. This example shows a standard Terraform IAM binding. The binding is used to assign the network user, network group, and network admin role on Project 1 and Project 2, and assign the App Engine user, App Engine group, and App Engine admin role on Project 1 and Project 2. The equivalent CFT module defines the role and user bindings for multiple projects within the same module.
I just hate how it ends, at least like a second.
T module defines the
So source is this, right? Project IAM makes sense. Module, right? Projects. These are the projects. Here, project one, project one, project one, project two user. Okay. It's binding role, network admin role to this user group in this. Here we are setting up use. So project one network project is this role member. Now we are setting up the network user, network group, network user, network group. So multiple people. Oh, okay. Yeah. So one for is for this network admin and app admin. Uh, okay. So four, two each. Yeah. App user, app admin. Okay.
the role and user bindings for multiple projects within the same module. In this lab, you will create two VMs in the default network. You will use variables to define the VM's attributes at runtime, and use output values to print a few resource attributes. You will then add a static IP address to the first VM to examine how Terraform handles.
So now we are going to work towards our Terraform um lab for and this is the video which will show us what we have to do and stuff, right? After this we can directly jump into it, or I was thinking today I will be using WSL
In this lab,
for
you
this.
will create two VMs in the default network. You will use variables to define the VM's attributes at runtime, and use output values to print a few resource attributes. You will then add a static IP address to the first VM to examine how Terraform handles implicit dependencies. Finally, you will create a Google Cloud Storage bucket by mentioning an explicit dependency to the VM to examine how Terraform handles explicit dependencies.
Go back.
Explicit dependencies.
Okay, you all know what's going on. I'm going to go now. Okay, create resource dependency with Terraform, right? You have this lab checkpoints, create static IP with explicit implicit dependency, so we don't have to define. We'll use the plan argument to see what is the dependency. Create virtual machine, so once the virtual machine is there, implicit again. Create cloud storage using explicit dependency, so I assume it will be dependent on the virtual machine. Virtual machine instance resource using explicit dependency. So explicit, I assume this will be either dependent on this or this. Okay, just getting some idea, right? No harm in that. Making some wild guesses. In this lab, you will create two virtual machines in the default network. I hope you are able to see these things, right? Okay, cool. You will use variables to define the virtual machine attributes at runtime and use output values to print a few resource attributes. So basically, we define virtual machine attributes, right? And whatever the output comes, we'll use those for so basically, the two explicitly dependencies we are going to define will be from virtual machine. That's what gives me the idea. We will then add a static IP address to the first virtual machine or VM to examine how Terraform handles implicit dependency. We'll then create GCS, Google Cloud Storage Bucket, by mentioning explicit dependency to virtual machine to examine how Terraform handles explicit dependency. Objectives. In this lab, you'll learn how to perform the following tasks. Use variables and output values. Observe implicit dependency. Use variables and output values. Observe implicit dependency. Create explicit resource dependency. So three things. Okay. Sign into Google Cloud Console. For this lab, you'll get a new cloud project and set a resource for a fixed time with at no cost. We have paid the credit, so technically it does cost us some 5 credit. Sign to Qwiklabs in incognito. I'll do it this way. Right, this will make my life easy actually. And I can just increase this like this. Go away, go away. Oh, I can do one thing actually. Oh, I wish I thought of it earlier. That would have made my life easier. Cool. Now this is much better. I do this a lot to get away with these annoying stuff, annoying panels and things like that, or especially also getting away with not paying for some stuff. Agree and continue. Let's just keep it like this. Will it be like too small to read? Or I'll just do it like this actually, so it's better. Sign into Cloud Console incognito, 1 hour 30 minutes. Make sure you can finish this within that time. No pause features. We know this. Cloud Console incur charges. We know that, right? So initialize Terraform using Cloud. Okay, I was thinking to use WSL, but okay. Do I want to? Maybe. Yeah, we have to set up the keys and CLI, but that's fine. We don't want to do that on my computer for now. So we'll go with this. Open Cloud Shell and execute the following command to verify Terraform is installed. So here is our Cloud Shell. We bring this up. Do it like this. You see, it's pretty cool. Like if you do it like this, just do it here. Yeah. See, it's here. One thing I want to do is open terminal, open editor. Okay, let's see how the editor comes. Last time we tried, the editor was not coming up. I guess, oh, this is Visual Studio Code basically. This is cool. This is cool thing they did. Open code OSS for Cloud Shell. That's cool. Kudos to Google. I can do this Terraform version. Let me do one thing. I'll just increase the font here, I guess. Terminal preference, text size, large. Now it should be clearer, much better. Let me just see on the cool. Should be better for you guys now. Yeah, watch it full screen. 1.7.2 AMD 64 Linux. AMD is everywhere. Terraform comes pre-installed in Cloud Shell. With Terraform already installed, you can directly create infrastructure resources. We are creating a new directory. Make directory on your Terraform configuration. Navigate to the running but navigate to it by running this. So mkdir make directory tf infra, so Terraform infrastructure, that will be the name of the directory, and so to and do this another command, which is go to this directory. Nothing is there, as you can see, but if you do, we were earlier here. In Cloud Shell, click Open Editor to open Cloud Shell Editor. We clicked here, we got this, right? To create a new file in the tf infra folder, right click on tf infra folder and click new file. I'll just do here touch tf infra, and what's the name here? Provider.tf. Okay, I'll do touch, but I want to show you like how. So no folder right now, or open folder. If I do tf intra, now is coming, no file inside it, right? I click refresh, no file is coming. I'll go here. Touch is one way to create the file. Nano is one, but it opens it. So now let's refresh. Provider.tf is here. Now let's see. Add the following code to provider.tf file. We have provider Google. This is our project ID, region, and zone. So here, to save, right, I'll just do Control S. Hopefully that works, or if not, file Control S does that. Okay, cool. Initialize Terraform by running the following command, Terraform init. Can I run command here? Okay, cool. I can run command here, then there is no need to even go back to that. Last time it wasn't working for me. Allow. Initializing background. So now Terraform is successfully initialized. This is like basically Git in it. All those things are very, very equal to Git. The output should look like this. Do not copy. This is example output. Initializing the backend, initializing provided plugins, finding HashiCorp, this, blah, blah, blah. Terraform was successfully initialized. Terraform has now installed the necessary plugins to interact with the Google Cloud API. Authentication is not required for API. Cloud Shell credentials give access to the project and API. So when you are doing it, you need to provide authentication through token, or it will pop up in the new window or whatever. But we don't, because we are legit opened it inside the Google Cloud Shell. So Cloud Shell does take care of that. Which command installs the necessary plugins to interact with Google Cloud APIs? Google init. Apply is to apply the changes. Plan is to like make sure all the things are there, right? Init is to initialize. Even it says, right, initialize. In the remaining part of the lab, we will cover two types of dependency with that Terraform can handle. Implicit dependency known to Terraform, explicit unknown. Explicit like implicit internal type thing, right? Explicit external things you are not aware of, internal things you are aware of. Task 3, view implicit resource dependency. To demonstrate how Terraform infers an implicit dependency, we assign static IP address to virtual machine instance. So basically what static IP is, whenever you create, even with your router, right? If you take your router off from the, don't do it right now, but like let's say in future, like in 1 hour after the stream is over, you took out the router, right? And you plug back in, you might probably will have a different IP address. This IP address keep on changing, right? You don't need it anymore. Somebody else will take your IP. So, and you will be given a different one. That's why servers at home is really hard to have unless until you ask your internet service provider ISP for a static IP. You can ask them. And that's what we are talking about here. Is we want to do the same static IP, same IP, no matter how many times we run it. We need one IP to be provided to us by Google. Google has bunch, right? So that's what we are going to do. Demonstrate how Terraform infers an implicit dependency. We assign static IP address to the virtual machine instance. Create a virtual machine instance. Let us create a virtual machine instance and parameterize its configuration by defining variables. To create a new file, right click on TF infra folder and click new file. Name the file instance.tf and then open it. Click and copy the following. Okay, so here we are creating. I'll just go here. If you see, a new file is created with hashes and all those. Okay, this is not we are going to church. It's law something. Instance.tf. Let's understand what this does. And let me just increase the font here. Or can I just, if it is, keep it 100, but if this is um extension, use a snippet, use a task. If this is, yeah, here we go. Yeah, this should be better for you all. This is Virtual Studio VS Code. I am very familiar with this environment. So resource Google Compute Instance virtual machine name var.instance name. So we need a TFR file here. var.instance zone. We need to define these three variables. Then in boot disk, right? I'll just do a extra space because I remember like these things, just keep a separate space. I'll put one here as well. Boot disk, initialize parameters, image, what type of image? Debian Cloud, Debian 11, which is basically Linux first version and main version. That's what Ubuntu, Kali and everything came from, still comes from. Network interface, network default, access config, allocate a one-to-one NAT IP to the instance. This is where we allocate the static IP address to the virtual machine. To save, click this. Okay, let's say. Now right click TF intra folder, new file to create a new file for variables, as I've mentioned, TFRs or variables.tf. All right. Name the new file variables.tf. I think there were 4 names, so you can give any of those 4 names. And then click OK. Add the following properties to variables.tf. Variable instance name. Type string. What is the type of the variable? Then the description, name of the Google Compute instance. Again, zone, instance type. This is string. This type of compute instance, default, right? Here, I'll just separate so it's easy to. Default is E2 medium. Remember default, if I do instance type, var.instance type, this will be the value going in. Remember that. By giving instance type a default value, you make the variable optional. So you make this variable optional because this will have a default value. Okay. The instance name and instance zone are required. You will define them at runtime. Okay, so if this is the default value, this instance type okay, this instance type become a default, and we don't have to, like, if we are not giving value here, we could have, we can't right now, but if we could have, then so okay, makes sense. I want to see this. This is cool. All the providers, calls and stuff. Cool. Variable.tf and stuff. Okay. Create output file. Right click output.tf, outputs.tf actually. So I'll just read it out for you guys. Right click on the TF intra folder and click new file. Create a new file for outputs. Name the new file outputs.tf and then click OK. Add the following properties to outputs.tf. Gotcha. So let's just read here. Actually, it will be easier because of the color coding. Output here, output block, network IP, name of the output, right? Name of the variable or output variable, right? Name or its value will be Google Compute instance.vm instance.instance ID, the internal IP address of the instance ID. Self link. We understand the link part, instance link, but instance ID, the internal IP address of the instance. Huh. Instant ID. Huh. Okay. I need to like do a good research on like because these names are not the best. Or at least this one is not the best in my opinion. Hopefully you guys find it easier. Assign a static IP. Now add to your configuration file by assigning a static IP to the virtual machine instance in instance.tf. So we provide this in the instance.tf like static IP, VM static IP, Terraform static IP. Okay, we are creating this new resource. Has to be outside this resource. So this is implicit, right? And I think we have to mention here its value will be Terraform static IP or basically output of VM static IP. This should look familiar from earlier example of adding a VM instance resource, except this time you are creating a Google Compute address resource type. This resource type allocates a reserved IP address to your project. So this you will get a special IP. I know in AWS, let's say if you have it's called elastic IP, or basically the word for static IP, and if you are using static IP with an instance, that's fine. But if you're not attached to an instance, then you have to pay for it. Update the network interface configuration for your instance like so. Network interface default NAT IP. So this is what we want, right? This is the only line we want. Yep. So net IP is network. Nope. NAT IP is basically network IP or network access. NAT is like I think short form for network access something. Network access terminal. Access translation. Okay. Or translation. So NAT, so basically the IP address of the virtual machine will be equal to this address, this compute instance resource, VM instance, and this address here. Its name can be anything, but its address, which is it's associated by Google. So the final code should be like this. We have I didn't do it up, instead I did it down just for implicit. I want to see better, but it's good to do it up because this is the independent one, this is the dependent one. I just did it because I want to see how Terraform will do it. Initialize Terraform by running following. That's a scam message I just got, but that's fine. Initialize Terraform by running the following command: Terraform init. Let's go to our bad boy here. Initialized. I think this might have changed. Did this change? Not sure. good. I don't want to open this. Run the following command to preview the resources created. Terraform plan. And I want to change the terminal. Let's go here, settings. Sorry, I did realize like for terminal it would be hard at least. Terminal font. At least I can do 20, right? Yeah. If not 26. And I'll do clear form plan, right? Enter value for VM instance name. So is there anything given here? Yeah, my instance, and I can type this US East 4C. It's working in the background, I believe. Sorry, but I want to show you why these two are coming. Oh, TF state, never mind. Region, right? We are provided for Google one, but variables here we have given instance name, instance zone, and instance type. We have given the default value to this, right? That's why it did not ask. And it's not asking anywhere else as well. Known after apply, known after apply. Okay, so if you see here, right? And now with the Google, like, I'll just increase this here. So you saw the output. These are the output will be known after. Here you can see instance link and network IP known after this, right? Because compute instance is still not created. It's just planned. Now let's look back at the variables, right? Our variables, instance name, instance zone. We provided that. Because we provided this, right? We don't have to, like, we just put it here. We don't have to write it down. It's already here. And if you see instance type, we just use getting the default value here. You didn't use the dash out option to save this plan, so Terraform can't guarantee to that take exactly these actions if you run Terraform apply. But let's just go here as well, just for the satisfaction. We put these two things. Terraform use the selected providers to generate the following execution plan. Resource actions are indicated. Create. Address type is external. Name static IP. So this is like because this is the implicit. This is not dependent. That's why it's getting created first. This is getting created later. Can IP forward? No. Detection false. There you got our name, project ID, stuff like that, and network default and known after apply. Here, cool. So let's do Terraform apply. I think that's what you have to do now. Yeah. If prompted, enter the following details. My instance. Oh, okay, never mind. No, I accidentally typed the wrong thing. Go up here. East 4C. That's good. It does confirm. I would have made a mistake there. My instance. Let's go. And then we have to type yes. Even yes, like it has to be all lowercase. Even the bigger case or something won't work. So we have error. Error creating address. Invalid JSON for metadata. Right? Google Compute VM instance resource. Error creating address post this invalid token JSON for metadata. And what is EOF? Meaning. Tag beginning, ending of multi-line string. Oh, okay. Authorize. Okay, sorry. This will work. My instance. Yes. Creating. Interesting that I don't think they mentioned here, right? Authorize and stuff. It's interesting. I would have been, I could have been stuck if I didn't click there. Still creating, so this time it's working. Static IP address complete after 12 seconds. So we got our static IP. We'll see in the console soon. Um, okay, cool. Everything is done. So we create a virtual machine was being created. Now it's still creating. It was done within 13 seconds. Apply complete. Resources to added. So instance link. Open. Now let's see what it says. Error 401 request is missing. Required authentication credentials. So we need to put some authentication before we can do this. So that's fine. We got the link anyway. Network IP. That's interesting. Well, I didn't get that. Network IP. What was network IP, right? Like instance ID. Network. It should be. This is the. That's what I was saying. Network. This is instance ID, not the network IP. Ah, why? I think this is one thing. Probably if they haven't changed in later, I have to mark this as a error. There's an error here. Okay, no output here, nothing. Okay, cool. TF state. Let's see what is here. Network IP and all those are broken, but address. This is what we needed. This is for static IP. So this is the 34. This you will should be here in the. If I do enter, should be the IP address of the virtual machine. Yep, machine type. This is the machine instance, right? Above here is the compute one. Sorry, static IP. This is the machine, and this is the IP address setup. Here, this is the IP address premium network here. But important to note, right? Like you will see the ID here as well, because that's one of the parts, one of the information given output to by the API. So ID here, right? Instance ID here. That's what is put. So I think there's something wrong with it, but I might be wrong, or I'll be jumping the trigger too fast. Observe that Terraform handles implicit dependency automatically by creating a static IP address before the instance. And let me just make this full screen because there's something here. Reduce this like the okay, nope. This should work actually, like it's coming anyway. So can I reduce this? Can I remove the drawer? Oh yeah, nice. Uh, there's no way to put full here. Nope. I wish there was. So yeah, man. Never mind. I'll just do Control Z here. I thought we could just, you know, expand it. That'll be nice. Cool thing to do. But that's fine. Not working. So let's not spend much time here. Now let's go here. Observe that Terraform handles implicit dependency automatically by creating static IP address before the instance. So we saw that right here. We saw that here. We first the IP address, then the compute instance was created, right? Verify on Cloud Console, right? In Cloud Console is the GUI Verify that resources are created in Cloud Console on navigation menu. Click Compute Engine VM instances. You should see our my instance. Verify the static IP address matches. So we have to go into the VPC network. Then we go to IP addresses, then external IP. So on the navigation menu, click VPC networks, IP addresses, external IP addresses, and Terraform static dash IP should be there. So let's do that too. And let me make this full screen as well. So Cloud Console, I can just do the take the Cloud Shell, small, create or select. I'm selecting my project, not create. I have to just go to navigation menu, compute engine, and click on VM instances. So we can see here my instance is created with US East 4-C zone, internal and external. And if you see external 35150, no, don't call this number, 35150 22986. Now if you go to VPC networks, okay, default one is here. I think instead of VPC network, yeah, IP address is here on the left. We see Terraform static IP 34.150.229.86, and if you see, it's attached by to this VM instance, and there are two IP. One is the external one, 34.1. 10 is the internal one. 10 or 196 ones or 192, I think. Those are always internal. This 35, 34 one is external. Okie dokie. And let's get going with something more. With our okay, check my static IP using implicit dependency. Check assessment completed. Check my progress to verify VM is created. This checks static IP as well as the VM instance. So we are done 25 out of 100. This is a long one, but we are very close because we are at task 4. So even though 25 points, I think all of them will go one pretty quick here. So now it's the create the explicit dependency. 3 things we are going to do. Explicit dependency are used. My camera is there. I have a habit of looking here, so sorry about that. I'll try look here. It's just the other screen where I can see my face. That's who I'm talking to all the time. But all good. Create explicit dependency. Explicit, as I mentioned, external dependency which Terraform cannot tell. That's what we are going to work on. Explicit dependency are used to inform dependencies. And I will just increase this. Sorry. Explicit dependencies are used to inform dependencies between resources that are not visible to Terraform. So we are informing Terraform about this so that when it creates, it actually is able to create it properly. In this example, consider that you will run on your instance that expects to use a specific cloud storage bucket, but that dependency is configured inside application code and thus not um, uh, visible to Terraform. So inside our code in the virtual machine, we created an app. That app has a dependency on cloud storage bucket, but Terraform does not know what's inside our code, right? So we have to explicitly tell Terraform this. So in that case, you can use depends on keyword to explicitly declare the dependency. To create a new file, right click on IFT intra folder, TF intra folder, and click new file. Name the new file exp.tf and then click OK. Alrighty, boss, we'll do that. Let me set it up. Yeah. Here, let's create a new one. exp.tf. What this guy is now saying to us: add the cloud storage bucket and an instance with an explicit dependency on bucket by adding the following base code into exp.tf. So let's see what we are going to add here. Let me take my terminal down a little bit and then put the editor here. Paste. Create a new instance that uses the bucket, right? Hash. So it's a common resource. Google Compute instance, another instance. Terraform instance 2, name, machine type is micro, boot, disk, Debian, network interface is default, access configuration not yet there, anything. Tells Terraform, now the comments are tells Terraform that this VM instance must be created only after the storage bucket has been created. And we have already given depends on in the array we are saying Google storage bucket dot example bucket. So example bucket will be the name of the Google storage bucket when we are creating here the label thing, right, in the resource tab. So we'll see this really quick. We have to probably create a new, add the following code to create a bucket. So I think we have to add the same code to same TF file, right? New resource for the storage bucket for your application use. New resource for the storage bucket our application will use. Sorry, it's like 12:41 a.m. and I'm like kind of tired now. Resource Google storage bucket, example bucket. Name is unique bucket name, right? So I'll just give it a, I'll check if it's not given, I'll give it a name. Location is US website. Main page fixed index.html not found 404. Okay, got it. I have to look at how what these mean, but that's fine. Storage bucket must be globally unique. Because of this, you will need to replace unique bucket name with a unique valid name for a bucket. Using the project name and date is usually a good way to create a unique bucket name. Yeah, no, I'm not doing that. I'll just do as oxgz is awesome. I'll use that. Save that too, boy. Check that. And so we have noticed that in our code, the VM instance configuration is added before Google Compute, Google Cloud Storage bucket, right? When executing Terraform apply, you will notice that the order that resources are defined in Terraform configuration file has no effect on how Terraform applies your changes. So what this means is basically you can have like the one like the cloud storage below the virtual machine instance, even though instance is dependent on cloud storage. Terraform doesn't care. It is smart enough to tell whether or not it needs that, whether or not which resource to put before, right? It knows all those stuff, so don't worry. The final code is as shown below, as show below, shown below. I will maybe. So we have resource cloud compute instance, all this information. Now we have unique bucket and stuff. Save this, run plan on this. Okay. Important that we run plan on this one, not the other one. Sorry, 1 second. Here. Okay. Does it detect automatically? Okay, never mind. It does not. This I don't have that compute instance, right? VM instance name. Did I mention? No, it already has that. So um I think I have to properly define Terraform plan instance name. Oh, okay. My instance and USE for run the following command to view the order resources, blah blah blah. Okay, never mind. I'll just copy this though first. I should use the dash bar already. This would have saved me some time. So now let's look a little bit here. Let's go away. Another instance will be created, right? Oh wait, yeah, it's here. So static IP address, refreshing state, Terraform have used the selected providers to generate, right? Another, so these things refreshing, so basically nothing happens to them, they're ignored type of thing. Another instance is created with these information. This is the name, right? Boot disk, blah blah blah, network interface, blah blah blah. And for storage, boot disk, does it mention about Google Cloud Storage anywhere? Network interface, access config, no, it just depends on, it doesn't seem to show up, up, but that's fine. Google's example one, right? Example bucket, OST site is awesome, standard, like, share, subscribe, pay. Don't worry, if you don't have to, you don't have to. I just love this, honestly. Compute instance, my instance, I have to use dash out, I guess, right? Like, so I can dash out option to save this plan. Yeah. Enter value. You want to perform Terraform will perform the following actions described, right? Bucket and all this are just refreshing state. Yeah. So if you see bucket is created first. Here, creation completed within second. That was pretty good. ID is OSD site is awesome. Another instance. Should complete after 13 seconds. Apply complete outputs. Cool. That's cool, actually. And so now what we have to do is, now we saw example bucket and then the instance was created. So apply complete resources. This is verify on cloud console, right? In cloud console, verify the resources are created. Compute, it's the same step. Navigation menu, compute engine, VM instance. We say the name of Terraform instance 2, cloud storage, and then we check. We can just check the progress now, it doesn't matter. 50 is already there, that's much. If you get an error, revisit the previous step to ensure that your configuration matches the lab instructions. If you cannot troubleshoot the issue of your configuration, download, then look at these finished configurations. So everything worked for us, we don't have to download. So, but I'll do this quickly, just for your guys' satisfaction. IP address, there will be 4, I believe, right? Refresh here, yeah. There are 4 because there is internal and external for any virtual machine 2 are there. You can tell, hey, don't have external one, but internal, I think you always need to have one. That's how Google plays. And you can see these are like 1 by 1. So it's 0 0.2, 0 0.3. These are like totally type random thing, whichever is available. This one will remain the same because this is a static one. So static, ephemeral, so it can change, right? We got that, right? And let's look at our virtual machine instance, Terraform instance 2. We'll see Terraform instance 2. I think I clicked the wrong one here. VM instances, Terraform instance 2. This is created. Now another thing we have to look at is cloud storage, buckets, monitoring settings. No, we have to just take the bucket. So we have this bucket. Just take this. OXG set, 0xg set is awesome. So that's our bucket, multi-region US standard. Last modified couple of minutes ago. Subject to object, ACLs. ACLs is basically like a firewall of IP addresses. Only these IP addresses can connect. So that's why you can define, okay, I only want my internal IP addresses of this range to talk to this cloud. How to say? I want only the internal IP addresses of the from this range to this range to talk to cloud storage. no external one. So that's like another type of security thing you can have when defining, right? Like, for example, I want IP addresses assigned to accounting group. Only these to have um, access to cloud storage, which holds financial information, receipts, accounting information. And this is important that only accounting people know who have who have like this need to know, not like the devs, because that's how internal this what's this called, internal data is leaked before um, the earnings report, right? Earnings report. So insider trading, that's the word, right? So that's how insider trading happen if the information gets leaked. So I'll just click here. Yeah, view dependency graph, so we can get the graph. We are done actually. Okay, cool. Task 5. View To view resource dependency graph on the resource created, execute the following command: Terraform graph dot svg. Okay, graph is switch to the editor and notice a file named this. Okay, graph.svg will be created. Click on the file. To understand how to read these, please visit this page. So I'll just post this page here first for you guys. So it's easy, right? Yeah. Okay, I'll do this. Good part is we don't have to switch to this guy again and again. Is graph.svg is here. Nice. We can do a preview. Open in live server, I think. Because this is like SVG is like the this looks like HTTP, but um no. Let's go back to how it's said here. To understand how to read this, please visit the page. Okay. Dependency graph, graph nodes, building the graph, walking the graph. How about this? Terraform graph SVG. It should look like this, right? Which it doesn't for us. So what I'm going to do is pretty simple thing. Go to the extension SVG. Install. This will install our extension. No need to open it anywhere or use our brain much. Verify SVG. Okay, never mind. It doesn't do what I wanted to do. Um, right. How to view SVG? Can I see the SVG? SVG preview. Preview SVG. Yeah, let's go. So you can see complete instance, another instance goes to and so our first VM instance is like dependent on this. So like this arrow means dependent on, another instance is dependent on the example bucket. Easy. No need to even like worry. Just download the plugins. Review. So we are at the end of our lab. Amazingly done. In this lab, I'll just read, right? Review. In this lab, You have a virtual machine VM instance with a static IP address to view how implicit resource dependencies are handled with Terraform. You then created an explicit dependency by adding the depend on argument so that you can create a GCS Google Cloud Storage bucket before creating a virtual machine instance. You also viewed the dependency graph that Terraform uses to trace the order of resource creation. You did everything, right? End of your lab, when you create, when you have completed the lab, right? So this is great. We have completed and all those stuff. End lab. Um, the errors in between and get instance the as output the output name given was network ID. Blender is I don't know how much they check. I'll just send them the email better for this. So I'll just keep it somewhere. Not Twitch. Fuck Twitch. I'm Slim Shady and I'm the real Shady. Slim Shady. Save. So don't have to do this anymore. So that's cool. I guess we can move to our next last thing of the day, our quiz. Um, Module summary. You know what we'll do is next time, because module summary is like kind of a recap, and whenever we do next, module summary will be a cool thing to do. Start with, right? So quiz. Writing infrastructure code for Google Cloud. Which dependency can be automatically detected by Terraform? Explicit dependency or implicit? Remember, implicit, internal. We know what's happening internally, not externally. So implicit. Can a variable be assigned? And again, if I make a mistake or what do you think about some of my justification or some anything like that, right? Like if my explanation was right or wrong, please let me know. I'm always ready to learn and get the idea. So thank you for that in advance. Can a variable be assigned values in multiple ways? Yes. If the ways here means is using dash var flag, right? Dash var flag, we can use tf vars like the file. We can use command line other CLI ways, or we can like one will be the export way. So yes, it can be assigned multiple values, different ways. How can output values be passed? Parameterize a resource configuration, declare a resource within Terraform configuration, print resource attributes using parameters, right? How many resource types can be represented in a single block? One resource in a single block. 75%. Okay. Review the lecture writing. Wait, how can output values declare a resource within a Terraform configuration? Print the resource attributes. Declare resource within a Terraform configuration. Okay, so maybe yeah, that's the one like through TFR. Nope, still no. Okay, so print. Huh? Get it like why print then? I'll need to like look into this. So Oh, used, not like. Yeah, in resource attributes. My apologies. I'm an idiot. So yeah, that's it, folks. This was a long one, but it was nice. Thank you so much for joining. I saw this was the maximum I have ever reached. It was like 8 viewers that like total with such a good average. So thank you so much for everyone. And there were like 4 people watching at one point. Thank you so much for joining in. Um, I got like 2 subscribers last week, so thank you so much for that as well. Thank you. Hope you have a great day. Jai Shri Ram, and see you soon. Keep learning and keep enjoying journey.